So basically, we just defined a few things. Just allow me to run through the slides, maybe for it to be easier. Yeah. Okay. So we just basically defined types of tokens, and we said that there are some different types of tokens, such as you can have a utility token, such as the ICP token, which is basically it's more of a utility token and also a governance token. It's a governance token in the sense that you can always convert it to cycles on the chain and get to pay for services. For example, if you're using NNS and all. Yeah. So we say that ICP tokens can be used to participate in decentralization of swaps to become and also to become a corner of an SNS DAO. And when using smart contract services built on internet computers such as registries, marketplace, and exchanges. So you can use the ICP token in different ways. Yeah. So the ICP token on its own implements an ICRC-1 token standard. So that's basically what we were doing last week. We were covering ICRC-1 token standards. So just basically said that maybe steps that you need to do when you're creating a meme token. You can follow these simple steps, such as of course have a good graphics. So choose the name of your token and a logo. Create a website for your meme coin. The good thing about internet computer is everything is on chain, so you can also just deploy your particular front end on chain with your preferred languages you use. You can write a smart contract code for your meme coin. You can deploy a smart contract code on ICP, and then after that, of course, create a liquidity pool for your meme coin, and then it all comes to promoting your meme coin. How you actually sell, that's actually always the hardest part. Yeah. Some examples that you can always consider in a meme token. You can always consider the minting and burning functions, whereby the minting is basically creating of the tokens, and burning is basically destroying the tokens from existing. That means at least when the supply of the tokens is less, let's say for example through people engaging in people send each other the tokens, and then the gas fees get to completely disappear, then at least it brings more value to that particular token. We also have a transfers and transactions functions, which are basically straightforward. They're just if you're dealing with a token, any type of token, it means that there's always a transfer of the token, so you can always consider that function as well. Okay, I don't know. Tita Taps is speaking. Maybe you can. Thank you. Yeah, another particular function you can always consider is the token metadata, whereby this is where a token needs to have a particular data. That means it needs to have a name, a symbol, of course the supply, and all the relevant information that contain that are considered in that particular meme coin. You can also use the posing and unposing transfers. So that comes to the transfer function. That is really important, especially if you want to provide control over the token's liquidity. And then also you have the token locking and vesting. It's always important. Maybe if you want to lock some particular tokens, you can always use your particular meme coin as a voting and governance token, for it at least to get value. Like we've seen this from real meme coins, for example, Dogecoin. Everyone knows Elon Musk is planning to use Dogecoin as more of a utility token and also a governance token for his particular company, whereby at least, if you're a holder, then yeah, it goes a long way. Yeah, you can always include token rewards and incentivization. For example, WorldCoin, the way when you check out their particular solidity code, you'll always see that that particular token has been created in a way that the way people get to receive the particular free world coins, those who verified their faces, their eyes, yeah. uh, for that particular feature comes in from that particular smart contract that has been written, whereby you can always tell that smart contract within this given time of period, release some of these tokens, maybe like three amount of 5 or 10 amount of tokens to this particular to holders to all wallets or all accounts that hold this particular token. Yeah, so that is always an important feature you can always consider. And then also another important feature is always the security. Yeah, you always need to run security audits for your particular smart contract, especially if you're dealing a token. You don't want uh let's just say recently attacks whereby someone can get to pose as an admin and get to actually rug the whole token into existence, maybe sends that particular token to his wallet, or ends up messing the whole system. We've seen that happening before. And then also token swaps and exchanges, you can always add that functionality, maybe if you want your token to be facilitated in a particular token swap. Yeah, and then also the staking part. You can always make your token stakeable. Your meme token stakeable in a way that when people lock it for a particular time or period, then they get to earn from that. Yeah, and then we defined different type of of tokens. We said the one that we are focusing on is the ICRC-1, which was the first token on the internet computer, the first token standard. At least it's stable. Basically, ICRC-1 is Internet Computer Commons. Yeah, but you're gonna see more definition of that. Yeah. Yeah, Internet ICRC-1. Yeah. Yeah, we're gonna see more of that. We have ICRC2. We have ICRC7. ICRC1 and ICRC2 are basically mostly the same. So ICRC2 is just an advanced. It has an advanced feature from ICRC1. Yeah. So you can always choose if you want to use ICRC1 or ICRC2. That is if you're talking stable tokens. ICRC7 is basically an NFT type of token. We have the IP20, which is the same as ICRC1 and ICRC2. It's just a basic token standard. Also on the internet computer, we have the IP721. It represents an NFT also. Yeah, it's just like ICRC7 and ECR721 for those who are familiar with Ethereum and the rest. We also have the EXT token, which is basically an extension token. So this is now any token that comes from another chain. You can always include it. Yeah. So ICRC1 is just a fungible token standard that provides a common interface for fungible tokens on ICP. Of course, ICRC2 is just an extension of ICRC1, like I said, but it has a few features such as the approve and the transfer from operations. Yeah. We also have ICRC7, which is just an NFT. Yeah, and also just the definition of DIP20. And we just something I forgot, instead of calling it DIP20, you can also call it Definity Internet Computer Token Standard. That's basically the whole full meaning for it. The acronym DIP stands for Definity Improvement Proposal. Yeah, so it goes on and on. We also have the DIP 721, which is an NFT, and then also the extension that I said, which is just extension token. It allows the following features such as multiple tokens which can be mixed. It can be a fungible and non-fungible token within a single canister. It's possible to create a token to be just a stable token standard. At the same time, that token is also an NFT. Yeah, so it's always good. So you can, so ICP has that, but you're not dealing with the EXTs today. Yeah, so the languages you're gonna be using for this particular sessions that you're gonna be running is Motoko, TypeScript, and Rust. Yeah. So today I'm gonna be using Rust. Next week we're gonna introduce one of the developers that has been on the SP community as well. He's taken part in some of our hackathons, and yeah, I think the project was also something that was dealing with tokens. So yes, we're getting to invite him. So him is gonna be doing a meme coin with Motoko. So today we are gonna be focusing on Rust. Yeah. So before we talk tokens, we said that there's one thing that actually you can't rule out. Yeah, and that is called a ledger. So a ledger is basically a place where it's just a type of record keeping where financial transactions are recorded. So for any token to exist, that means any in the world, any token that you know in any chain, doesn't have to be ICP. In any chain, there always has to be a ledger somewhere that is responsible for the transaction. So the ledger is just is responsible of carrying the database of that particular token. Yeah, so maybe if there's transaction somewhere, then there has to be a ledger. Yeah, so internet computer has an ICRC-1 ledger. Also the same way to for example, I'm hoping maybe next month, maybe after the Bitcoin halving, we're gonna start doing like we're gonna be building on Bitcoin and stuff. So maybe you're gonna be CKBTC. So even CKBTC, the way it is as a token, it also has a CKBTC ledger. Yeah. So all tokens need to have a ledger one or another. So this ICRC-1 ledger is just a ledger canister that keeps tracks of accounts. It maintains the set of accounts owned by principals. Each account is associated with a token's balance. Accounts owners can initiate the transfer of tokens from the accounts they control to any other account. Yeah. So this is an example of how our particular transactional dashboard looks like on internet computer. When you come on this link, you can always check out how it looks like. So when you're here, you can always see real time the internet computer ledger canister and how it works, how it's responsible of all these particular transactions and stuff. You can always get a whole breakdown of that. Yeah. So there are three main ways you can use the ICRC-1 ledger. For us today, we're gonna be using we're gonna use it as more of an installation library. Yeah, but you can call it by doing the whole command of the FX canister call. You can use the Internet Computer CDK canister developer kit. You can also use the ledger ICRC which I think we're gonna use partly. Yeah. So ICRC-1 is just a token standard created by the Internet Computer Working Group. ICRC stands for Internet Computer Request for Comments. I think it's the same as now when when you're talking to about Ethereum ERC-20 is Ethereum request for things for comments. I think Ethereum request for comments 20 or something. So I think it's just almost the same way as internet computer. The only difference is ours just call it internet computer request for comments. Yeah, so we said that there's some features that need to be included when you're actually considering to have a token. For example, the first part is where you store your data. So where you store your data, there has to be an account, and for that to be an account, then there has to be a principal somewhere that gets to have multiple accounts, can get a sub account. Yeah, basically there has to be just the main account mostly, yeah, and then now the other accounts. And then you also have some particular methods, such as this particular code that you're seeing. These are Motoko types of code that basically yeah, they define the ICRC-1 standard ledger canister. On its own, we have whereby you have these various types of methods where when you run them, for example, this one runs it returns a name, returns a symbol, a decimal. We have a fee, of course, the metadata, token supply, the minting account, which is always really important. Minting account is always the account that is gets to create these tokens, and then of course there has to be a token that has a balance and the rest, yeah. And then yeah, and then now we went to how to set up an ICRC-1 ledger. So I want us to dive in there quickly. Today I'll try and keep time at least. Yeah, so I've opened my terminal. So since we said we're using Rust, maybe something you need to know about Rust is Rust is a modern systems programming language. Focusing on safety, speed, and concurrency. It accomplishes these goals by being memory safe without using garbage collection. So maybe maybe an important feature you need to know about Rust. The whole breakdown of all this is basically Rust gets to clear its own code. Yeah, it's like when you come up with a Rust code, when it compiles before it does the whole deployment process, it gets to actually autocorrect itself in a way. So for example, if maybe you gave a code that maybe that code someone can actually run their particular piece of code and it gets to tamper your whole application. So Rust has a benefit of at least it has a benefit of let's just say keeping you secure in a way, yeah. So that's why most people have actually at least jumped on the Rust side, yeah. So we're not gonna go deeply into the basics of Rust and all because of time. But you can always check out the Rust book. I think I can try to just post it on the chat or something. Okay, even if I don't, yeah, I can post it on chat. So that's basically, you can just check out the Rust book. Just learn a bit of Rust. But if maybe we have more time in future, we can always check out the step by step thing about Rust. So maybe if you don't know anything about Rust, don't worry. I'll try at least to explain as basic as possible. So first of all, let's create a new project. Yeah. So we're gonna create a project called let's call our project Kadudu. Yeah. Let's call our project Kadudu. Basically, yeah, that's the name of our project because I want our meme coin to be called Kadudu. Yeah, so we're gonna select when you do DFX new, I'm gonna select Trust. Only for the front end, I think I just can just use simple vanilla JS. Of course, I want internet identity and init. Yeah, so it's gonna create for me my particular uh, project. So first thing is I'm going to insert the ICRC-1 ledger. You see, last week we basically did a whole setup of how to set up your ICRC-1 ledger, and then get to see how to actually deploy that particular ledger canister. Um, so today we are gonna, since our project also requires us to do that, we're still gonna do it, but we're just gonna go furthermore. So I'm just waiting for this to create, and then then it should be good to go. Nice. So our project has created successfully. Let me just open it. Do I think I put capital K, and then open it with VS Code, and boom. So we have a particular default project. This is basically our Rust project. As you can see, it comes with a front end, it comes with a backend folder. The backend folder is basically where we're gonna be coming up with our backend canister code, which our main file is gonna be here on the lib.rust file. And then also it has, of course, the cargo.yml file, which is important for the whole assembly language, Tom's language. And then I think it has even deployed its own particular Rust code. And then we have the front end, which we said you're just gonna be using simple index HTML and CSS. Yeah. I think maybe we can also just call it Kadudu meme coin. So this is just 10 years something for the front end. We're gonna make our front end more better, but today we are mostly dealing with the particular the backend. Yeah, so our next step is so this is the backend folder, front end folder. We have important folders that we have, like this dfx.json file. Basically, this is what defines our canisters, how they're gonna be deployed with dfx. Yeah. So what I wanna do is I wanna like include the ICRC-1 ledger, because I think it's only fair if we want to create an ICRC-1 meme coin. So it's only fair that we also input the ledger, so that at least our particular meme coin can get to carry out into transactions. Yeah. So I'm first gonna set up I'm gonna run this command. So what I'm doing right now, I included it in the particular GitHub folder that I actually shared last week, but I'll still do it. But basically what I've done, I've just run this particular command that just confirms to me that at least I have like the latest I have like the latest I have the latest ICRC-1 ledger files. Yeah. And then the next step after that is there's a particular command I'm looking for. I put it on the documentation. Let me just check right now. Yeah. So we have that. Let me just confirm ICRC-1 latest. Yeah, so I'm sorry for that. Let me see if I can run this particular command. Yeah. So this is the command that I was looking for. So I have basically run a command over here. So this particular command basically it just sets up the ICRC-1 ledger environment, on your particular project. So I just ran that command. It's also included on the particular tutorial, but I updated some features on it. So after this, I'm just gonna push the entire code. So just after this class, you're gonna be able to see actually how that comes about. So it after running that particular code, I got these two files. Yeah, I have this WebAssembly file, which of course you cannot view, and then I also have this ICRC-1 did file, but I can see they didn't come in well. Let me just confirm right now. Particular ledger canister. Yeah, okay. So yeah, so once you have that, then this particular file that I'm looking for. Yes. Yeah, so I can see here that it shows that this file has been moved permanently. The reason is because I already set up my ICRC-1 ledger somewhere else. So I'm just gonna replace them with it. Let me remove this, and then I just so this is actually what I'm looking for. So we have these two particular files that come in immediately once you run this particular command. Yeah, that sets up your WebAssembly. I said you run WebAssembly, and also I think I'll just need to can remove this, but yeah, it's not really important. Yeah, but these two files are really important. The ICRC1.did file is basically the candidate file that confirms that this particular canister has been deployed. Yeah, it shows that ICRC1 is in existence. So after having these two files, you also need to check your dfx.json file over here. So here under canisters we have because the backend canister and the front end canister, you will be required to also define the ICRC-1 ledger canister, which how I'm gonna include it is so I'm just gonna add this particular yeah, I'm gonna add this particular here under canisters. Okay, I'm just gonna add it after this. Yeah, so I'll put a comma. Let me see. Yeah, so basically on this dfx.json file, I added the ICRC-1 ledger canister. Basically this one just it just represents that ICRC-1 is it's literally over there. Maybe another feature you can always add over here on the dfx.json file you can also include internet identity. Now this one comes for the front end. Yeah, this one is applies mostly for the front end side, but the most important one is this one that we added over here. But you can always and then our backend file is this. Let me just confirm that the files are okay. Dependencies, you can maybe say, we can add a dependency that our particular we can add our dependency over here that our particular backend code is using ICRC-1 ledger canister, and then of course something else maybe is can add declarations. Yeah, let me see declarations. I think I'm missing a comma. So just added that, and then the front end is okay. So I just wanted to say you can add internet identity for the front end, because assuming we'll make a front end for this particular canister. So I think for the front end I'll just need to I can use like source assets. I'll just define it after here. Let me see. Let me hope it doesn't give me. There's something I've gone wrong somewhere. Okay. Identity. So it's just maybe a particular comma that might have. It's okay. It's okay right now. So that's for internet identity to be there. So mostly that internet identity feature is now for the front end part. You're assuming that maybe your particular app will use we'll use internet identity, but the most important feature you should realize is this the one we added on the dfx.json file is ICRC-1 ledger canister, and also of course we just added some features about it like a dependency for it. So with this already installed, with this already just changed, without even me coming to the particular Rust code, it shows that our particular canister can be able to deploy an ICRC-1 ledger canister. Just the way it is right now, it can be able to deploy. And last week we did some of that, but you're also gonna be doing it today. But we want to also define our particular meme token. So I'll just remove this particular code over here. Of course, on the basics of Rust. For example, if you're creating any line of code for Rust, for example, let me do this. Basically this code that you're seeing over here is just an hello world statement. So this is just an example of a statement that shows if I was to run the Rust C, and then I name this lib.rust folder, and I run it on my terminal, it will just basically give me hello world. So Rust has a unique way that it actually does its own code compilation. But I personally think Rust is not really complicated. Maybe for most of you, maybe who haven't explored it, the only difference is it's just like basic JavaScript. The only thing is some things have been changed. For example, for JavaScript, a whole function will be function or func or something. For here, it's just fn. So it's just as easy as that. And then also the print line is more like a Python code, whereby if you want to come up with the particular output. So we want to define our particular code. And some of the features that we would like to have here are the features that we were talking about. Like for example, let your token have a token name, let it have number of supply, and everything. So the first thing that I'm gonna be doing for our particular code, we're gonna do some imports. So first step is which imports are you using. So this is a random Rust code that I have come up with. In case it has bugs, it's for us to fix it. Yeah. Um, so first of all, I'll use the hash map import, um, which basically just imports the hash map data structure from the standard library, and then I can also import the a candid type and a principal, which these imports are for candid serialization. It's just a method of serializing data for communication between canisters. I'll also import the NAT type, which just represents natural numbers for candid serialization. And then I can also import ICRC-1 ledger canister, which just imports the ICRC-1 ledger canister, which is just being used over there. So sorry about that. So now let me do those particular imports here that I described. So I'm gonna be using these imports. So allow me to just copy paste them, and yeah, these are the particular imports that we have that I was actually defining. Yeah, we've just imported the hashmap standard library for managing the token ledger. Of course, you're gonna be importing the candy type and types for serialization. Basically, this is mostly dealing with now our data, and then also we want to use ICRC-1 ledger. Yeah, so that's why we actually imported it over here. Yes, so let me close this. Yes, so let me close this. You can see my machine is running on high heat, so I'll just close one. Yeah, that's done. Yeah, so once you're good with that particular imports, yeah, of course, as you can see, our code shows that it's like it has a bit of bug or something, so that means we are not done. Importations are always important if you're building with Rust on ICP. Also, I think in almost all languages, the first thing is always the importations part. So maybe over here you might see it looks like it has an error, but it's because we are not actually done. Yeah. Let me just confirm that all my imports are correct. Yes, I can see that based on the description tutorial I came up with that they are correct. So the next thing is now that is the most important part. Once you're done with the importation, now come to the data. So on the data part, we are gonna be using our struct definition, something called struct. That's basically where you get to it's a primitive type on Rust where you get to actually import your particular data. So this is actually where we're gonna be doing our whole definition that this is an ICRC-1 meme token. It defines the structure. It has this particular ID, it has this name, it has this symbol, it has can give it a token supply and stuffs. Yeah, so I'm gonna do that, but I'll do it in a very, let's just say I'll do it in a very sincere and and easy way. Yeah. So I'm gonna allow me to just get my particular code here and then also copy paste it. I can do line by line, but I'm just trying to save time. So this is actually what our structure looks like. As you can see, even as on it says define an ICRC-1 meme token canister. So the first word over here is a struct. Yeah. It's basically where you come up with your whole particular data on what you're building. So for example, ours is it has a token identifier, it has a token name, it has a token symbol, it has a total supply, shows that we are using a ledger, meme URL, which has a string, and then meme description also has a string, and then meme creator. You can also put a name over there. Maybe to make it easier, I'll just try and maybe define our particular meme coin. Yeah. Yeah. Okay. Yeah. So we are not done. We're not actually done. I've checked out my code. Yeah. So another implementation that you want to put in over here is this particular piece of code. So don't worry, I'm going fast a bit because I've already done this, but at least I'll give you guys time to just go through this. So I've actually added this, this particular implementation over here, which basically now gives us a brief overview of what we actually defined over here, on our struct field. We basically just implemented the meme token that we described over here, and this particular piece of code just says that we are initializing an ICRC-1 meme token with these specifiers. You can give it a description as you want. You can give it a creator can also be a string. A string basically can be a name. So actually I want us to focus on here. So I said our token is called Kadudu. So I defined ours here as I just called it Kadudu. Yeah. So that's basically just now this is why it shows that the to string or something. A string can be a name or a symbol. Yeah. Ours is also our symbol of our meme token will be KD. I think maybe I can put. So no, KD is okay. KD is okay. Yeah. Total supply. Of course, there has to be a ledger. Meme URL can actually be a string. For example, if I wanted this particular piece of code to just have maybe that particular photo that I want for my meme is coming from somewhere, then I'm just gonna do the same thing I did up here. I think I'm just it's here, and boom, I can actually define my meme URL. For example, maybe if it's in this particular link, then maybe that's actually by URL. That means maybe you can set it just the image of the meme, the image of that meme token, maybe how it looks like. Probably you're fetching it from an online site or something. You can always pull it up as a string also. Of course, this particular field doesn't exist, so I'll just leave it right there just for the sake. And then now we are going to the third part. Is we are going to the functions part. So for the functions part, that's actually where you can always get the constructor functions. Basically now that's where you get to implement those features that you are saying. For example, if you're implementing the transfer operation, the balance operation, the minting, the banning, the meme creator, and stuffs. There has to be a bit of function implementation over there. So you can use different methods. So for ours, just allow me to fetch it from my end. So for ours, it will be this. First of all, if you're talking functions, you should always know that um, yeah, if you're talking functions, you should always know that functions have like you can always have a public function or uh, you know just a private function. So that comes to the whole basics of now like learning Rust, which we're not doing today. But yeah, there's always public and private functions. So first function that we've actually defined over here is the transfer tokens function, which is basically this particular piece of code that you're seeing over here. Basically, this is responsible of just showing that there's a there's a transfer, and in case there's an error, maybe if you're transferring from one account to another, you can always see if that particular account does not have um, enough balance. You can always see there's insufficient balance. It will return insufficient balance. Of course, if the account does not exist anymore, you can always see account not found. Yeah. Another function we've added is just to get the balance of the tokens for a specific account. Yeah, you can always use that. It's actually important. We have the mint tokens. Minting is basically what we said is now creating. Yeah, there has to be an account that is a minter. Yeah, that actually gets to mint the tokens. Yeah, we also have the banning of tokens. So this one, banning of tokens is basically now it comes in from for example, if you don't want tokens to exist completely, at least you can always implement that feature. I think almost all tokens implement those features, even these meme coins that maybe you're seeing at the moment from I think the most famous blockchain right now that has a lot of meme tokens is Solana. So like for example, when you check out some meme tokens in Solana, what the developers always try to do is to ban, like they always report they can post on Twitter or anywhere that we've banned this amount of token, so that means it doesn't exist. So we always try to ban tokens so that the value of your particular token can go up, because at least there will be less scarce supply, like the whole. Yeah, let me not go deep into all that. Yeah. And then also we have another function which just basically gets the meme creator. Can be a string, name of person or image. Also, and then you have the final think. Yeah, and then you have a final function that that is responsible for fetching the meme descriptions, just description, just a function that fetches meme description. Yeah. So after this, of course my code shows like it has an error. I'm trying to figure out why it's showing that. I think I'll check out this. Check it out right here. I'll check it from here and confirm why we are having an error. Yeah. Let me see. Okay, so I'm trying to see where this particular error is coming from. Let me give it time to load. The next step is basically deployment. I can see we have 5 minutes. We said you're gonna be focusing on time. Let me start my DFX. Okay. Yeah, so let me start DFX. A moment. Yeah, so effects already runs, and yeah, now let's come to the deployment part and see how this goes on. I can first deploy the ICRC-1 ledger canister. Of course, to deploy it is actually not that hard. You just basically you first of all need to have an identity. An identity is basically what is responsible for you to have your particular. It's more like a wallet. It has your wallet. When you are dealing with cycles and you want maybe free cycles, you always need to have an identity. So, for example, for me to know my identity, uh, I'll just check the identities that I have. So I have mine. We wanted to use Minta. Last week we used Minta and Ledger. So let me just create a new one. DFX identity. New. Let's call ours. Let's just call it Kadudu. Yeah. So yeah, and then we're gonna be using it by running dfx use. Dfx identity use. Sorry, Kadudu. Yeah, so we are using the Kadudu identity. Next command that you're gonna be running is you're gonna run this particular command, which just gets just tells us that this particular identity, this is now our minter. This is now our minter identity. This is basically where now our tokens will be coming from. You can always export the token name. For example, ours is Kadudu. Wait. Yeah, token name is Kadudu. Of course, give it a symbol. Since it's ICRC-1. Yeah, we say that is KD. Yeah, and then now we're gonna switch to our default identity. So I'm gonna do dfx identity use default. Yeah, so I switched from, we first we just ran this particular commands on our new identity called Kadudu, which will be our minter. Our minter account, and then now now we've switched to a new identity, and then of course give it this particular command that I'm about to run here. I love the whole process. And then maybe you can do prevented tokens to be maybe 10 billion. Yeah, and then we can put the gas fees to be wanted to at least have the 0.001 gas fees. So these steps that I'm doing right now, this one is coming on the ICRC-1 ledger mostly, yeah. And then I'll just basically let me change ICRC-1 leads new. Yeah, you can also insert some features such as maybe set who you want to be the controller, something. Let me just run this whole particular command at once. Identity already exists. Yeah, new controller. Let me use this. Oh yeah, it already exists. Yeah, so it's okay. Get principal. You can also use this if you wanted to implement ICRC-2. Yeah, and then now coming to the deployment. Let me see before I run the FX deployer. So I just basically ran a command to deploy our ICRC-1 ledger canister. I'm gonna see if it works. But what I want is also when I run the FX deploy, that is gonna deploy the ICRC-1 ledger canister successfully. But let me see if I do the FX deploy if our particular canisters will actually deploy, or we have to check this particular, or if it has an error in any way. So let's see if multiply our backend of front-end canister and front-end canister. Yeah, intelligent identity canister. Okay, so we have to wait for deployment. I hope we don't get disappointed. So maybe I might have rushed a bit maybe on here and on the Rust code, but don't worry about it. The project is already open sourced, so you can always check it out. You can contribute if you need. You can, yeah, and I'll also update it. I'm actually doing another update on it just right now to this session for you guys to follow. Our time is up. I'm just waiting for this to deploy, and then I finish up. We will trying as much as possible now to strictly keep time. Yeah, so that when you have other people who are running the sessions, they can also implement the same. Okay, so fingers crossed. But if there's an error there, we all know it's it won't deploy successfully. But I just wanna show you the whole process of it. Because I don't think it's fair if I show you guys everything and then we're gonna be having a minton. A minton is basically just a hackathon whereby the whole agenda. I can see my Rust code has an error. The whole agenda of that minton will be come up with a meme token, and the best meme coins will win. So mine has refused to deploy. I think it's because of this particular I guess fixes that I have to actually do on my end. But basically I just wanted to leverage mostly here on the ICRC-1 canister that deployed successfully. Let me open it. Yeah, this ledger canister. Okay, yeah, I think it was opened on this side. Yeah, so here's our ICRC-1 ledger canister that deployed. Our Rust code fortunately had an error. I don't know where it has come from. But I'll just fix it. Right now. Let me just move here. I want you guys to see our ICRC-1 ledger canister. So if you're building an ICRC-1 token, part of what you need is this particular ledger canister, which has different methods such as get blocks, of course, get data certificate transactions. The particular methods that we were showing in the particular slides, the decimals, the data into account the name and symbol to supply standards of course allowance of the transfer form methods. Yeah, you can always call them over here. But on this particular project that we were doing over here, once you do effects deploy, I'm gonna go through this particular code after this here, and then just push the updated code that doesn't have this this particular error. But basically, once you define your polygon, it's also gonna deploy the backend canister. So you see all your canisters over there, once and for all, and yeah, actually that's what you need. So the whole tricky part or the whole game changer comes in here, how you actually implemented your particular Rust code. No, how did you actually define it? Yeah. So I think we're good to go. At least from here, I believe that now the ball is in your court. I think I'm supposed to only show you guys a brief overview, and then the rest is for you to do it on your own. But I'm updating this particular GitHub where we actually do the whole thing. I want to update it right now, and then you're gonna see the full canister code. You can use it, but of course don't plagiarize it for future use. But you can always just check out how it looks like, and then see how you can define yours from there. Yeah, so sorry for eating 8 minutes of your time. Like I said, now we want to just strictly follow time. So I'm gonna push it back to Steve. We're gonna dim this session for now. So next week, we're just gonna see also the same thing, but should be done with more talk.
Okay, nice. Thank you, Chavi. Yeah. I think we'll just end the session. I don't think there's anything we can add or minus.
Yeah, so Steve, over to you.
We'll send the recording. We'll share the recording by tomorrow. Yeah. Thank you guys for joining in.
You're welcome.
You're free to leave. Yeah.
You're welcome.